All right, so today's lesson is about simplifying rational expressions. And another way you can think about it is a rational expression is just a very fancy word for a fraction. Now the big idea here is we're going to have to factor and then reduce and then factor. This is huge. You have to factor and then reduce and then factor. What are we looking at here? You can only reduce factors. Now that's important to remember that factor is used in two different ways. So as a noun, which I'm using here, a factor is something that's part of a multiplication problem. So if I look at this first example here, there are no multiplication problems, so I can't reduce anything. So what I need to do is to get factors, I need to factor. So as a verb, factor means rewrite something using multiplication. So the number 50 could be rewritten as 50 times 1. The number 100 could be rewritten as 50 times 2. So now that I have factors on top, I have 50 and 1 as my factors on top, and 50 and 2 as my factors on the bottom, we can reduce common factors. So you might want to add the word here, common. So I can see that 50 and 50 are both common factors, which is why this fraction reduces to 1. Now if we look at the next example here, 2x plus 1 and 2x plus 6. These terms, like some people are going to want to cancel the 2x, but that's 100% wrong. Never do it. I'm trying to cancel this. That is not a factor. This is not a part of a multiplication problem. This is part of an addition problem. So unfortunately, I can't cancel that 2x. Same thing down here. This 2x is part of an addition problem, not a multiplication problem. Now unfortunately, there's no way to rewrite these, so I can't rewrite them as multiplication. So this is already simplified. Now, we said we couldn't cancel these two x's because they were part of addition problems. But down here, we can cancel those two x's because I'm trying to cancel this thing. And this thing, that 2x, if I look at the symbol that's between the 2x and the x minus 3, it's multiplication. So this thing is participating in a multiplication problem. Same thing down here. This 2x that I'm trying to get rid of is only being multiplied by x plus 1. So as these are only being multiplied, these are factors. So I can cancel those common factors. So the way this would reduce would be to x minus 3 over x plus 1. Now looking at the end, we're going to be tempted to want to cancel those two x's again because we just said this 2x is being multiplied by x minus 3. Unfortunately, we have to look both ways though. This 2x is a part of this term here because it's joined by multiplication, but that 2x has an addition sign in front of it. So this thing is a part of an addition problem, not a multiplication problem. So we cannot simplify this one. I'm just getting rid of my work to say that this is already done. This is already simplified. So doing actual problems, this is your go-to method. You're going to factor the numerator and denominator, which of course just means rewrite as a product, so using multiplication. Reduce, meaning cancel your common factor. And then the idea of repeat is you just want to make sure your answer is correct. Could you keep going further? So looking at 15b divided by 25b squared, I'm going to plan ahead and think about what common factor would they probably share. And first thing I realized about 15 and 25 is they both share a common factor of a 5. So I think I'm going to use 5 as a multiplication. I also see that they both have b's. So I'm going to rewrite 15b as 5b times 3. I'm going to rewrite 25b squared as 5b times 5. So I can see that 5b and 5b are only in multiplication problems, so they are common factors, so our final answer is just 3/5. Approaching this one, it doesn't matter where you start your factoring, and in some cases, when I look at the top, I'm not exactly sure how I should rewrite 12c squared. There's a bunch of ways. It could be 4 times 3c, it could be 4c times 3c, 2c times 6c. I'm not exactly sure what way I'm supposed to do it. So in this case, I'm going to start on the denominator, because when I look at the denominator and I see that linear factor, I can see right away that it has a common factor of a 3 on the bottom. So I'm just going to rewrite the bottom as 3 times c plus 2. I'm going to use this as a context clue. If I'm going to cancel some factor on top, it's either going to be this factor of 3 or this factor of c plus 2. So which one of these would help me rewrite 12c squared? Well, obviously c plus 2 isn't going to help me with rewriting this. So because I see a 3 on the bottom, I'm going to try to rewrite 12c squared using a factor of 3, which would of course be 3 times 4c squared. So as I can see here, the 3's are common factors because those 3's are only in multiplication problems. So we're going to cancel the 3's, which means we're left with 4c squared over c plus 2. Now repeat, I can't factor the bottom anymore. Don't be tempted to cancel those c's. You can't, because this c is in an addition problem, not a multiplication problem. So when I'm looking to repeat, can I factor the numerator anymore? Can I factor the denominator anymore? And I know that since I can't factor the denominator, there's no factors to cancel, so this is going to be my final answer. Now in a problem like this, I see a linear factor on top and a quadratic on the bottom. It literally doesn't matter where you start. You just have to factor either of them. On something like this, I'm going to start with the numerator because it looks easier to me. I just see that they have a common factor of a 2. So if I pull out the 2, I'd be left with z minus 1. Now on the bottom, I see a quadratic. This quadratic has a leading coefficient of 1. So my organizational strategy for this is, I remember we're looking for a sum and a product. We are looking to find numbers that multiply to 3 but add to negative 4. So those numbers, of course, are negative 1 and negative 3. So I'm going to use those to write my factors. So my first factor is going to be z minus 3, and then my next factor would be z minus 1. So now I go back to the original context of the problem, and I see that there's only multiplication on top and there's only multiplication on the bottom, and I do see that they have a common factor of z minus 1. So my final answer is going to be 2 over z minus 3. I know that's my final answer because when I'm trying to repeat my process, there is no way for me to factor 2, and there is no way for me to factor z minus 3, so I can't get factors, so there's no factors to reduce. Our final example is a really great example to look at, so we all know right away that we can't cancel those c squareds. There are multiple reasons why. First of all, because that thing we're trying to cancel, this c squared, is not a part of a multiplication problem. It's being a part of a subtraction. So we can't cancel that. Down here we can also see that this c squared is not a factor. It's not being multiplied by something. It's actually being added to something. So that's one reason we can see that we can't cancel the c squareds right away. The other reason we can't cancel the c squareds right away is because it doesn't follow our pattern. The reducing or canceling happens second. We never cancel first. We always need to factor first. So do not cancel those out. Absolutely not. Never ever. So what I'm going to do, I'm going to use my organizational strategy again as I did on the last example. I recognize that these are quadratic and the leading coefficient is just a 1. So up on top here, I'm going to do that one down here in green. So I'm looking for numbers that would multiply to negative 6 but add to negative 1. And those numbers multiplying to negative 6 are either 1 and 6 or 3 and 2. So I'm going to use negative 3 and positive 2 as my factors. So on top, I get c minus 3, and then the other factor is c plus 2. Now the denominator, again, leading coefficient is 1 and it's a quadratic, so my organizational strategy is what numbers multiply to positive 6 but add to 5? Well, also, I'm actually going to use 3 and 2, because 3 times 2 is 6, 3 plus 2 is 5. So on the bottom, I'm going to get c plus 3 and c plus 2. So my common factor, looking at the top, there's only multiplication between those two factors and only multiplication there. I see a c plus 2, so I'm going to reduce those factors, which is going to make our final answer, which I'll write here in red, just c minus 3 over c plus 3. I know that's my final answer because I'm trying to repeat my process. I cannot factor the numerator. There's no way for me to factor c minus 3, and there's no way for me to factor c plus 3. And of course, we know that we cannot cancel anything. We can't cancel those c's because these c's are not a part of a multiplication problem. Same thing with the 3's. We can't cancel the 3 because this 3 is part of a subtraction problem, and this 3 is part of an addition problem.